Put it down. It glows when it's scared.
How would you know? He's mine.
Just because you caught it and put it in a jar doesn't mean it belongs to you.
It's not it. It's Henry. Henry lives here now. Don't you, Henry?
That's new. May I be excused?
You haven't touched your meal.
Food you can eat without teeth. My favorite.
Sometimes I miss Dad's cooking. Sorry, Mum.
Sometimes I do too. I've washed your uniforms for Monday. Excited? How are you feeling, Mol?
It's like you said. There's no changing it. Can I please go now?
Just eat.
I don't feel well.
Cramps?
Gross. No, I just want to be alone.
Oh, that's new for you.
Oh, shut up, Till, you moron.
Molly,
What?
don't speak to her like that.
Sorry.
Don't speak to me like that either.
Oh, what, Mum?
Do you have any manners?
Do you even like me? Do you? Do you?
I'm your mother, Molly. I'm not your friend. It doesn't matter if I like you.
Power surge detected.
Is that Henry?
System's back online.
Hello, everyone, and welcome to Inside Unreal, a show where we learn, explore, and celebrate everything Unreal. I'm your host, Tina, and to get us started today, I'm going to walk through some news and also the community spotlights for this week. So first up on the news agenda, for those who may not have heard, I'd be surprised if you haven't by now, but some of you may not know, but Unreal Engine 5.6 preview is now available. It's available for download on the Epic Games Launcher, GitHub, and Linux, and you can also check out the public roadmap to see more details about all the cool features that came out. Just a quick synopsis of some of the stuff that did come out with 5.6 was vast high-fidelity open worlds with maximum performance and consistent 60 Hz frame rates, the biggest and most powerful update yet to the animation authoring toolset. MetaHuman Creator is now available in Engine, including blending and sculpting of metahuman bodies, plus improved visual fidelity and new real-time workflows for the MetaHuman Human Animator, as well as faster creation with Content Browser 2.0 and the new viewport toolbar layout, the ability to build expansive, high-fidelity worlds faster than ever with powerful procedural workflows with PCG. If you're interested in learning more about what's coming with 5.6, I also highly encourage you to tune into State of Unreal, which will actually be broadcasting live from Unreal Fest Orlando on June 3rd. And if you're not attending the event live, that'll be available on our Unreal Engine channel at YouTube, LinkedIn, our Twitter account, as well as LinkedIn. Next up on news is we had a really cool interview recently with the Chump Squad's lab rat. I'm going to be messing up a lot of this. I'm so sorry, everyone. But this is a really awesome project that was put together. These days, everyone seems to be pondering the impact that AI will have on the design and development of interactive entertainment. Although this is a hot topic, indie developer Chump Squad's president and primary developer Gwen Frey has been exploring this concept for quite some time. In fact, her exploration of these ideas date back to her loneliest days in isolation, even during the pandemic. However, rather than wrestling with the unknown, Gwen gave herself an outlet by creating the unique and satirical Lab Rat, which presents itself as a puzzle game developed using machine learning technology and showcases the hilarious flaws that result from such methods. So, what is the game really all about, and why did Gwen and the small team at Chump Squad choose Unreal Engine 5 to achieve their goals? We tested Gwen with a few questions to find out. If you're interested in seeing the full interview about this awesome project, you can do so at unrealengine.com/feed or follow the links that we just dropped in chat as well. Then lastly, for news for this week, we're excited to announce that our Unreal Engine education team is launching a new beginner course that is currently available on the Unreal Academy platform, the Epic developer community, and here on YouTube for those that are here watching on YouTube. Take your first steps towards game development with the 2.5D game course. It's designed for beginners and taught by industry experts. This comprehensive course will equip you with the knowledge and skills needed to develop a game in Unreal Engine. The course comprises of 7 mini courses and covers key topics to get started with Unreal Engine using 2D assets and plugins. You'll learn the foundational skills to develop a game, including engine navigation, blueprint integration, plugin management, working with materials, and world building. By the end, you'll be ready to create your own experiences from start to finish. All you need is a passion for gaming to take this course. Creativity and problem-solving skills are also a plus, though. So if you're ready to learn, you can take the first steps today by following those links and just watch the tutorial series. Follow along. Hopefully you'll learn something fun and exciting. Then lastly, for the spotlights for this week, community spotlights is something we do. We always like to take a couple of key, really cool projects that have popped up in the community recently and highlight some of them so you can see some cool stuff folks have been doing. So the first one that we want to show you is Moss Gardens by Guillaume Hecht. Now, Moss Gardens is an incredible personal project based on the concept art by GXY. It was aimed at exploring new workflows and shaders, specifically working on transitioning from urban to organic environments while tackling the impressive task of creating all assets, materials, shaders, tools, and textures on their own. They created a detailed biome set piece with multiple points of interest and navigation elements that feel natural and immersive. Everything you see was built and rendered in Unreal Engine 5.2. It was handcrafted with no AI, scans, or 3D library assets used in its creation. If you want to check out this whole project, you can do so at their art station, which is linked in chat. The next spotlight for this week is Anderson by Jian Baoju. It's based on the concept of Tooth Woo. It's a character project that pays special attention to expression through posture and environmental storytelling, integrating details that enhance the narrative of the piece even at a quick glance. Showcasing impressive texturing and shading methods, the juxtaposition of Anderson and his wife, and the extremely varied approaches to both left us wanting to know more about the world they were crafted for. You can check them out on their art station as well. Then the last spotlight for this week is called The Projects by Philip Sperrick. The Projects by Philip Sperrick is a large-scale environment project that showcases a massive city, like truly huge. I cannot emphasize enough how big this project is, that is both fully modular and fully real-time. It was created in Unreal Engine 5 using key features like world partition, nanite, and lumen. Prefabs were assembled using PLAs in a world partition map, combining a whopping 1,500 unique static meshes, 25 handcrafted city blocks, 29 unique building prefabs with their own interiors included, which is insane, 44 modular road prefabs, and 26 arrangement prefabs to create a sprawling metropolis with all original materials and blueprints. This was a truly impressive undertaking, and we were completely blown away by the results. We hope you feel the same, because this is insane. It's incredible. If you want to see more of this project, because there is a lot to see, also highly recommend that you go check out their ArtStation on this project as well. With that, that's everything for this week's news and community spotlights, and we'll get into the show for today. So we have one incredible guest with us here who's going to be talking about mobile development and some approaches to it. So Sam, hello.
Hi.
Tell us a
Can
little bit about yourself.
Okay. So my name is Sam Deiter. I've been making video games for almost 19 years now. I've spent 10 of those years at Epic. I've had kind of two roles while I've been here at Epic. I used to work on the documentation for UE4, and now for UE5, I work on the internal instructional team where I train various clients on like how to use the editor for different industries. My focus is in games, but I touch pretty much all areas. Animation is something that is not my forte. That's about it. I know I know a lot about the editor, but that's about it. So yeah, I enjoy using Unreal because it's very powerful. It's almost like a digital like toolkit for creating whatever you want. Really, if you had like a barn full of tools, to make furniture or something like that, I feel like Unreal is kind of like that. So yeah, that's it for me.
Well, awesome. Thank you so much for being here today and taking the time to chat with us about this topic. Speaking of which, if anyone has questions while we're going through the talk today, please feel free to drop them in chat. We'll be collecting them for a Q&A segment that we'll tackle at the end of the show after the presentation. But with that, Sam, I figure I'll just hand it off to you if you want to get us started today.
Let's go ahead and cut over to my screen now. And all right, so we're going to be taking a look at the following areas for mobile developments. We're going to start with some mobile shading techniques, which shading method you should use, various things like that. Then we're going to look at mobile rendering enhancements, techniques to improve performance. We're going to take a look at performance and optimization techniques, and then finally debugging and profiling. So we've got about 40 slides to get through. So let's go ahead and get started with mobile shading techniques. So Unreal offers two different types of shading methods. So there's a forward shading. So mobile forward shading, the benefit of this is that this is going to work with a lot of devices. This is going to be the most simplistic version of rendering that Unreal Engine 5 is going to provide. And the reason for that is because it works best when used with pre-computed lighting. So you're not going to have any super fancy dynamic lights or anything like that, but you will have something that runs very fast, and you're also going to have multiple anti-aliasing options. Instead of TXAA, there's MSAA or FXAA. There's a bunch of different ones that can be utilized. The drawbacks to using mobile forward shading is going to be limited dynamic lights and reflections. So remember, we're using baked shadows, so we're going for speed here. So our reflections and our shadows are not going to be as vibrant or as interactive as they would be if we were using a different renderer. Materials require more runtime and memory. So basically, if you are utilizing this and you're using a bunch of materials, not material instances, but materials, they're going to require some extra commands for lighting and things like that. And this is going to increase your overall memory footprint. It might be negligible, it might not be, but if you're trying to hit lower end devices, this is something you need to consider. And it's also going to be prone to hitching. That is just kind of one of the drawbacks of previous APIs, is the hitching that happens when you run into a piece of content that is not accounted for and it needs to compile it. There are some things that you can do to try to account for this, but you just need to know about that. That could be something that could happen as your project grows in size. Things could hitch. When do we want to use this? Well, any project that uses pre-computed lighting. So let's say that you're using Unreal. I need to take a drink real quick. To build something like a match 3 style game, or a card game, or something that doesn't really require, like, you can get away with having the shadow underneath the character as like a little circle. That would be a good use for this. Or a project that requires a lot of use of like local lights or point lights or spotlights. Maybe you have a racing game that uses a bunch of street lights or something like that. The forward renderer might be something, and you use spotlights for the street lights. The forward renderer might be something that you might want to consider. And this last one, this is a little bit more technical, but you're targeting non-tile-based GPUs. So tile-based GPUs are like NVIDIA Teragen, Samsung Eclipse, and Power VR. These are older devices. So these are going to be lower-end devices and cheaper phones because they are older. So if you know that you are going to be targeting a device like this, then this is going to be a better option for you due to how the renderer is split up. The other thing that I want to talk about is this right here is a link to the documentation page that is going to talk about pretty much everything that I just mentioned, but in more detail. And you're going to see one of these for each of the slides that we go through. So this will just take you right there. So let's talk about now to mobile deferred shading. So this is the second option that you have. So what this does is this actually separates our geometry and lighting into two separate passes, is where before we had everything done in one pass. And the benefit of this is that we're going to get better performance when we have a complex light and geometry setup. Let's say that we're running a massive open world. We want to run at 60 FPS, then we're going to want to use the mobile deferred shader because it is more suited for content like that. If we know that we're going to a tile-based GPU, and the reason that I keep bringing this up is that tile-based GPUs, there was kind of like a leap in technology. Tile-based GPU is going to be like an ARM, like a Mali or Arduino and Apple GPUs. I can never say that one. I always want to say Arduino, but that's not the same. It's not the same thing. The reason that I say this is that those higher end and tile-based GPUs are like the GPUs that are like in phones now and like higher end phones, and that's kind of like where the tech is going. The mobile deferred shader is going to give you better performance because of the chip architecture on that phone. Can't get into the details about it because it's way out of my area of expertise, but it has something to do with how the memory is split up to help do things. The mobile deferred shader is set up to work with that in a better, more optimized way than the forward renderer is. There's also support for high quality features, or support for features like high quality reflections, multiple dynamic lights, and lit decals. So more of the higher end features that you would be used to using are going to work. So the editor is going to work, or I should say features in the editor are going to work more in parallel with their PC counterparts. It might not be exactly one-to-one, but it's going to be closer than it would be. The drawbacks of using the mobile deferred shader are obviously you're going to require a higher end mobile device. So if you were targeting a device that was maybe 5 or 6 years old, it's probably not going to be possible. Or if it is possible, it's going to require a lot of testing or a lot of edge cases to make sure that you've covered everything, so nothing like doesn't show up or something like that. If you do decide to use mobile deferred shading and you want to use pre-computed lighting for some reason because you like some of the information that it gives you, you're actually only limited to being able to use default lit and unlit. So you couldn't use something like subsurface or some of the other lighting modes because they will not work. And you are limited to anti-aliasing. And I forgot the name of the method. It is, I believe, TXAA. When you should use this is on projects that have a lot of dynamic lights or really require like dynamic shadow interaction. So let's say we're making a massive open world. We want a day-night system. That's going to where we're going to get the benefit of mobile deferred shading. On top of that, again, to reiterate on this, massive open world. So if I'm working on a massive open world, it has an extensive outdoor environment, mobile deferred shading is the way to go with that. And then again, we're targeting tile-based GPUs. So if we're targeting higher-end GPUs, then this is going to give us, even if our project is not using a massive open world, it's still going to run overall better on that tile-based GPU. So, and again, here is where we can get some more information on mobile deferred shading. So, high dynamic range. So high dynamic range, or HDR, you can disable this to make your project run faster, but you're going to get a lot of drawbacks in terms of how your artwork looks. So the benefit of enabling this is going to give you a better range of colors and brightnesses. It's going to allow lights to cast dynamic shadows, and it also will allow you to use post-processing features on mobile devices. If you disable it, your project will run really fast, but you will not be able to use any of those features. The drawbacks of turning this on versus leaving it off is with it on, it's going to increase your project runtime memory and rendering performance. It's going to increase the base requirements for your devices. And sometimes it can introduce specular aliasing, but this is not something that you need to be too worried about. You can actually reduce this by enabling the material property normal curvature to roughness, if you should experience that. When do we want to use mobile HDR versus non-mobile HDR? Well, if we're looking for, say, more contrast and our shadows, let's say inside of the light and the dark, we're starting to see some really blocky shadow compression, then we're going to want to enable this. This is going to give us a higher range of blacks and just grays and values like that to work with. If we want to use features like bloom or maybe depth of field inside of our post-process or use a post-process material, we're going to need to enable mobile HDR or HDR to get access to features like that. And then last but not least, if we ever want to use any dynamic lighting on a mobile project, we'll need to have this enabled in order for that functionality to work. There is going to be some more information about mobile HDR on the HDR lighting page right here. So you can take a screenshot of that really quick if you want to. And now we're going to talk about mobile versus deferred. So basically, when should I use one versus the other? Like, should we put them together so they can fight? And so here is, so forward, better performance on lower end devices. It supports MSAA for enhanced visuals, and it is going to be a reduced memory and power consumption. Sorry about that. Deferred allows for more advanced lighting techniques, supports for multiple dynamic lights that can also be shadow casting lights, and supports for advanced post-processing techniques. That's going to be like, vignette and chromatic aberration and things like that. When should I use? Well, deferred when you want to use a lot of dynamic lights or high-end rendering features. So if I want to have a huge open world that's does bloom and depth of field and exposure and all that stuff, I'm going to want to use deferred. Forward is when you want to reduce build size or power consumption as much as possible or hit as many devices as you want. That's when you're going to want to use forward. There's a bunch of other things that will go into this, and it's not that one is better than the other. It's like, for example, sometimes you need to use a screwdriver that is a flathead for some screws, and sometimes you need a screwdriver that is a Phillips head for other screws. One is not better than the other. They're just two different tools to help you accomplish a similar task. So in this case, your forward render could be your Phillips head screwdriver, and your deferred could be the flathead screwdriver. And when to use them, well, whenever you need to get a screw out, depending on the shape of the screw, is when you're going to want to pick one versus the other. And this guide right here is going to give you a little bit more information about how to make that choice. So, all right, so cruising right along, we're going to talk about mobile rendering enhancements or techniques to improve performance. The first thing we're going to talk about is AMD's Fidelity FX Super Resolution, or FSR. This uses temporal upscaling to produce a high resolution image from a low resolution input. UE supports a mobile optimized version of FSR, yes. FSR, I have problems with abbreviations. FSR 1.0, and it implements a slightly reduced quality version. But when you enable this and set it, you can expect between a 2 and a 4 times increase in performance depending on what you're using. There's a full precision and a half precision. So if you use full precision, you'll get about a 2 times performance increase. If you use half precision, you'll get about a 4 times. The performance versus the trade-off in quality is so significant that you should probably be running with this by default. The reason it's not enabled by default is Unreal runs very lean, or as lean as it possibly can be. So that's why this is a plugin that you will need to enable. We'll cover this in the next slides. The only really drawback to using this is if you're using some type of post-processing that has like an intentional noise pattern or is very noisy, you could get some unexpected artifacts. So like if I have a really finite noise, or I'm using the film grain or something, there could be some unintended consequences for stuff like that. But other than that, everything else should just work. So this next thing right here, this is actually, it's incredibly easy to use. Once you've enabled the plugin and restarted the engine, you just use the following command line arguments, and you can actually do this right inside of the editor. So you can go inside the editor or on your mobile device, do the 4-finger tap, pull up the console, and then do, our mobile FSR enabled. And then this first, or not this one, this sharpness right here, this is like a 0 to 1 value. And you can adjust that. And that's pretty much all you need to adjust. The other default settings here, like the denoise and stuff like this, has already been pretty well tuned. You can adjust it if you want, but the main value that you really always have to do is just this sharpness to get that result. So here is the mobile FSR documentation pages, so you can get some more information on this. And again, the coolest part is that all you have to do is just like enable it. You don't even have to expose the parameters to the end user. You could if you wanted to, but you could just enable it, tweak it, and then set it in your INI, and you'll be good to go. All right. So mobile frame pacing. So what this does is this allows rendering of your application at a lower frame rate than the device's native one. And this is basically a benefit when you're trying to prioritize consistency and stability for a smoother experience. So basically, if I am making a game and I know that my menus can run at like 5 frames a second or something like this, I can use mobile frame pacing to, instead of running at 30 FPS, set them to run lower for whatever reason. You can also set this on a per device basis. So let's say that your project works on like 100 devices, but you notice that on the lowest 25% of your devices, or take a step back. You have 100 devices, they all run at 60 FPS, but you notice that the lowest end devices, they're having issues with menus when they come up running at 60 FPS. They're like totally tanking the frame rate or something like that. So the menus don't need to be super interactive. So maybe when the menus come up on these 25% of the devices, you have their frame pacing to reduce it maybe down to like 30 FPS or something like that. The drawbacks to this is, well, since we are now going to kind of do this on a per device basis or across, regions of, 25, 50, 75, and 100, we're going to add overhead that needs to be tested for. And also, this is more of an Android-based approach, and due to the fragmentation in the Android community, because Android is a software, so like it can have a million different types of phones and requirements. There could be edge cases where this actually makes things not work as well as it's intended, or it has the reverse consequences or the reverse actions. Maybe instead it slows everything way down too much, and that can be very hard to test for. When should you use this? Well, when you need consistent and smooth frame rate across maybe all of your menus or something like that. You want to target a wide range of Android devices with a bunch of different settings, so that you know that you can just ensure that there's a smooth process across all of them. If you're experiencing frame hitches when you're going, say, between menus or something like that, this is also mainly used when you get into like HMIs or human machine interfaces, or things that run on like automotive, or maybe you work on like a gambling machine or something like that doesn't need a menu to run at 30 FPS. You can set this so that the menu now runs at like 2 FPS. Or maybe your game goes idle for after 5 seconds, the game goes idle. And then in order to save battery, you take the FPS of the screen and you put it down to 1 FPS. And then when they come back, it goes back to normal. So there's a bunch of different ways that you can use this. Here is the documentation page that has some more information about setting this up and how you can enable it inside of your project. All right, so performance optimization techniques, tips for project optimization. And the first one we're going to talk about is mesh auto instancing. So what is the benefit of this? Well, it will reduce your mesh draw calls, will help lower your memory footprint, and improve your overall rendering efficiency. And basically what it does is it goes out and looks for meshes that are the same. So let's say you have like 30 cubes and 30 spheres and 30 triangles, and they're all mixed together inside the level, but they're all in the viewport at once. What mesh auto instancing will attempt to do is take all of those 30 spheres and all of those 30 cubes and all of those 30, or I said 50, I'm sorry, rectangles and all of that stuff, and batch them so that the cubes are all with the cubes, the triangles are all with the triangles, the rectangles are all with the rectangles, and the spheres are all with the spheres. The drawback of this is that this benefits CPU-bound projects rather than GPU-bound projects, and device compatibility varies. So what could work with one device and one set of content might not work on another device, and it could have the opposite. It really depends on if the hardware is there to support this. And effectiveness is also highly dependent on the project. What this means is that projects that have many unique meshes won't benefit from this. But let's say that your project is made of maybe 6 or 7 static meshes that have all been scaled and rotated and positioned in a way where it looks different, but when you really break it down, the world's only made up of these 7 objects. Then a project like that would really benefit from something like this. But if you had a massive open world project that had 300 unique meshes, it might not benefit as much. When should you use this? Well, if you are a project that is CPU bound and not GPU bound, that means that you are constrained on the CPU and not the GPU. This is going to help. Going to help reduce the amount of mesh draw calls you have or the amount of times you're talking to the CPU. That's always good. If you have a lot of repeated assets like rocks and trees, so maybe you have 3 or 4 rocks or 3 or 4 trees that are all repeated, then this is going to be a good thing to enable for your project. Or if you're using lots of procedural generation of assets, mesh auto instancing is going to help with that. So let's go ahead and go to our next slide here. Or, well, I should say not our next slide, but we will go to the documentation page about this. And then we are going to go on to our next slide, which is going to talk about OODLE data compression. So OODLE data compression, what is the benefits of this? Well, it's going to make your packaged games smaller to download. It works across many platforms, and it's fully integrated with Unreal. So when we go to pack our PAK or our IPA, this was automatically going to be used for creating that and compressing it as small as possible. Now, the drawback for using this is that OODLE's texture compression is not supported on any of, or it's not supported with ASTC, so it's not supported, period. And I just realized that my drawbacks relate more to CPU, because I was just realized that right now. But basically, the only really drawbacks to OODLE is lower end CPUs can have problems with hitches, because it's just one more thing that has to decompress. And super old device compatibility may be limited. When do we want to use this? Well, whenever we want to minimize our game build size for distribution. So let's say we want to take our APK from the store and it's like 190 megs. We want to compress that down, maybe get rid of 20 or 30% of it. We can enable this and see the results that we can get. And the best part is we don't actually have to do anything else. We just enable PAK compression, and OODLE will be what is used. You can also use the Noodle network package compression. So that will help compress network packets, making any mobile projects. And this is great because this works cross-platform, but it also works on mobile devices. So the only thing out of the OODLE toolset that doesn't really work on mobile things is the texture. Everything else, the package compression and the network tools work. And you can also use this to help improve updates and patch timing while reducing size. So you can make your network packets smaller, make your package sizes smaller using OODLE. And that's just going to help users, with download times and also getting back into the game faster, because the less time that they have to spend there unpacking things or downloading stuff means more time that they can get into your project and play. So, all right. There is our QR code. Totally had a brain almost fell out of my head there for where you can get more information on how to use this. And let's go to Animation Budget Allocator. All right, so this is a tool that constrains the computation time allotted for animation running on specific skeletal meshes. So let's say you had a skeletal mesh for some NPCs, and I don't know, you wanted to reduce their time on specific platforms. You could do that. So reduce the time that they tick, so maybe they're not fully animating. And this is really, really great because once you set this up, the system kind of runs behind the scenes without really any need for user input. So you establish the amount of milliseconds you want this system to use, or that these animations should use, and the system is automatically going to take what you've done and then budget that in a dynamic way for you. Main drawback to this is it's not really going to work that well on super low end devices, because you can only work with so much. So you might experience some stitching or some stuttering. And when you use this, well, when you want to have a lot of animated skeletal meshes in the view at once, or we need to reduce our animation overhead on a per platform basis. Let's say that on a high end, Pixel or Samsung Galaxy, the latest version, it's running great. But as we start to go down to previous generations, maybe we're down at the 3rd generation, which still looks really good, but we're having issues, then we might need to enable this in order to just trim some of the fat, so to speak, or trim some of that data so that we can have a frame rate that works and is interactive. And basically, if we want to maintain a consistent frame rate across a wide range of devices, this is something that we're going to enable, and this will help us ensure that things aren't going to go faster or slower depending on what device you are. Everyone's going to have the same experience. And here is our documentation page that will cover where you can get more information on this. Okie dokie. All right, so material quality settings. So what this does is this allows a single material to function across multiple platforms. And it does this, or the other benefit, I should say, is that it's going to reduce issues from unsupported features on certain platforms. And the best part is you can preview all of this from right inside of the material editor. So this is a node that you'll place inside your material editor, and what you can do is you can set it up so that it says, on desktop, it will render this version of the material, while on console, this version will get rendered. And then on mobile, it will render this version. The drawback of this is that it will increase the complexity of your material. It's not going to increase necessarily the instruction count, but it's going to increase the visual complexity by adding variations for different platforms that you support. This also is going to increase the QA testing. QA now needs to test your various material quality settings to ensure that things actually show up the way that they're supposed to. And lower end visuals might suffer. So it might not be that possible to recreate what you have created on a lower end. So this could end up, although it's not a bug, or it doesn't not work anymore, it just maybe doesn't look as good, and it's just not possible to make it. You should use this whenever you want a fleshed out user setting system. You want to give the users maybe something like, do I want to set this to high, medium, or low? Or if you're working with cross-platform, you can expose it to the user. You don't have to, but you could also say, hey, whenever my game is run on a console or a mobile device, I want you to set the material quality settings to their lowest possible, or to medium or something like that. And this is also a great way to help maintain your style. So let's go back to the lower end visuals might suffer. Since you know this, you might design your artwork in a way so that everything maybe has like a texture fallback or something, so that you're not using such high-end features that lower-end devices just cannot compete. This is a great way to help make sure that you can still maintain some art integrity and have full control over everything. And there is the documentation page for the material quality settings. And you're going to notice there are quite a few things inside of there to check out. So it's a really great page to have a look at. Okay, so we are about a little bit more than halfway through. Is everybody doing okay? I hope so. All right. So now we're going to talk about debugging and profiling. And we're going to talk about tools to help optimize performance in UE5. So Gauntlet Automation Framework. So Gauntlet is a, I call this like a big boy toy. I don't mean that in a derogatory way. I just mean that Gauntlet actually would require like an engineer, a very talented technical artist, to get set up. And what it does is it is a framework to run things to validate to run tests and validate results. It's specifically designed, but not limited to, running Unreal sessions for a variety of platforms, and then giving you some information about what happened. So like this game ran, it opened up a multiplayer client. It spawned in 2 players, but then it crashed before it could like successfully exit or something. You can use this for mobile testing, right? Load up the game on this mobile platform and then, see if it happens. But it is a very complex tool because you can do so much with it. So the great thing is that it doesn't really require any specific game code or framework to work. So it's not like you have to learn like the Gauntlet, Gauntlet's programming language or things like that. It works with Unreal. It's just getting it set up with your project takes some time, and it also requires maintenance. That's why I say kind of like a Gauntlet engineer, because in any studio, this would be somebody's task. probably fall on the poor build engineer. And it also allows for really complicated testing configurations. Like I said before, let's think about this. I load up a game. I got to load up 2 multiplayers, or load up a game, load up a server, have two clients connect. Like that's a big test. Like that could take me 10 minutes to do. Now, if I have Gauntlet do this for me throughout the night or something, it can run through all those tests and then provide me everything while I'm off looking at the results and filing bugs. So again, the drawbacks: initial setup can be a daunting and time-consuming task, and it requires regular updates to make sure that your tests are accurate. So you have to update the test cases as your project matures so that what you're testing for is actually relevant to the current state of your project. And it's going to need to be maintained by a programmer or a technical artist throughout the lifetime of your project. It's not just kind of like a set or forget. You're going to want to use this when you want to test across multiple platforms, or you're going to run daily tests for crashes, asserts, or fatal errors, or if you want access to save data from devices after testing. This is a way to get all of that information in one place and make it really easy to look at that data once you have everything set up. Now, this is the Gauntlet setup documentation pages, so please take a look at that because it does require a fair bit of setup. But what you will get is a complete suite of tools that make it incredibly easy to run automation testing in the editor once you have everything set up. So, all right, so Unreal Insights. So Unreal Insights is a telemetry and capture analysis tool that allows you to look and track events from your projects at really high data rates. It's really useful when you're trying to look for a specific optimization, especially when you're dealing with C++ code, or you have integrated maybe some of your own code and it's not running as fast as you want it to or as you think it should. This can help you figure out why. The benefits of using this, again, it can be used to identify performance issues on the CPU and the GPU. You can also use it locally or over a network. That's right. I can even get a utrace on a computer that's running on my same network without actually having to go over to that computer and do that. And you also have the ability to specify what data to include or exclude. So I can specifically look in a utrace file to say, hey, include all of these line traces, or when I enter a volume or something like that. Some of the drawbacks, again, this is like a big boy toy because it is going to require that you do some C++ work in order to add your own traces. This also might not account for third-party plugins that you are using. So let's say that you maybe got a plugin from the marketplace and it's performing slowly, and you go to run a utrace to try to get a detailed analysis and it doesn't show up. That's because it's only written to see things inside of the engine. You might have to extend it to see those things inside of your plugin. And also knowing what data to look for can be challenging because this is showing you everything that is happening by the microsecond inside of your computer. So it is a massive amount of data. And if you're not really sure what you're looking for, it could be staring you right in the face, your issue, and you're just not sure because, or worse, you don't even know where to start to look. When to use this tool? Well, to figure out if your project is CPU or GPU bound, basically if your project's running really poorly and you've made a bunch of optimizations, maybe you've turned off all of like the post-process and you're staring at a wall and like everything has been set to 0, but your project still runs really, really poorly, this is a great tool to help you dig deeper into that and really see what is actually causing issues there. Also, if your project's taking a really long time to load or something's taking a really long time to activate, this is a way that you can see what is blocking that loading time or why it's taking so long to load. And it can also help you get a deeper understanding of your project memory usage or network traffic. So if your project consumes a lot of memory, this can help you see what is consuming all that memory. Or if you are running a network project, you can use this to see how the different clients are communicating with the server, and if there's any errors there, what they might be, and how you might be able, not how you might be able to go about fixing them, but just if there's any errors there, so you have a better idea of how you might be able to fix your code. And this is the page for documentation about Unreal Insights. And it does take a little bit of setup to do. And it also does work best if you have a C++ project, but you can use it with the binary build of Unreal. All right, Android game development extension. So this is actually kind of cool because this is a plugin for Visual Studios that allows you to have the same Visual Studio profiling and debugging tools, but you can use it for your Android products or Android projects. So right now, what you have to do is if you want to use you have to use Android Studio basically, which means that if you have a C++ project, you've got to have Visual Studio and Android Studio to basically do everything that Visual Studio can do, but you still have to have them both open. So with the Android game development extension, once your project has been built and launched on your device, you'll be able to use Visual Studio just like you would debug any Windows application. So basically what this does is it rolls all the goodness of that Android Game Studio requires and puts that into Visual Studio. The really only drawback about this thing is that it takes the specific setup to get it working. But once you get it working, the best part about it is that it's going to reduce the amount of tools that are in your pipeline, because now all you have to do is just use Visual Studio and all of the tools that you know from there in order to debug your Android projects, which makes it a lot easier to do. All right, here is some information about where you can get more information on how to use Android debugging in your project. And our next thing that we're going to talk about is device profiles. So I love actually device profiles. I think these are pretty cool. What they do is they allow for platform-specific optimizations across a wide range of devices. And you can get very big with device profiles. You can say on all PCs, or you can get very narrow, all PCs with this specific GPU, or all mobile devices that have this type of GPU in them. You can also use them to specify which features you want to enable or disable too. So again, I could say, PCs that get some automated score can have, nanite, but if they get a score below this, nanite will be disabled. The drawback to this is that the initial setup is daunting. When you open up this tool, there are just hundreds of options. It could be a little scary to set up. It also might not be possible to account for every single device that you could think of. It might not be able to catch everything. And by adding more devices, we're going to be increasing QA's workload. So, while this is great at making sure that we can reach a wide variety of phones, we are going to need to make sure we're testing all of this, and that's going to fall on. Hear me?
And 1 second. There we go. Okay. I was trying to figure out if that was on my end or not.
No, hold on. So I don't know why, but sometimes my microphone just turns itself off. So, all right.
It's fine.
All right. Where did you guys lose me at?
Just the past couple seconds.
Okay. All right. So, we'll go back to the drawbacks. So the drawbacks of the device profiles, the initial setup is huge. There's a lot to do. And also what is presented in the editor is just what Fortnite uses. That's not all the devices that are out there. If you look at like your Google store listing for your APK setup, you'll see there's tens of thousands of devices. And tens of thousands is not an over exaggeration. There are thousands upon thousands of devices in there. And you could set up one for each one that your project supports. It is in a massive time sink up front. With that said, though, it might also you might not be able to account for every single device because there just could be too many to configure for. And then this is going to increase the complexity of QA testing, because the more devices profiles that you have means the more things QA is going to need to test for. You should use this whenever you want to create any cross-platform So if I know from the beginning that I'm going to do PC, but I'm also going to go to mobile, possibly console, then setting up device profiles is going to be something you want to do to account for all of that. You also want to set these up when you're trying to account for a wide range of PC specs or just a wide range of hardware. I know I'm going to support VR and console and this. Well, this can be a great way to ensure that it runs, but when it runs on like Xbox, it uses these settings versus PlayStation versus PC. And then when you are, especially on mobile, you want to account for a wide range of chipsets and capabilities. And it doesn't matter if it's Apple or Android. You could use this to go from all the different generations of iPhone that Unreal Engine 5 will support, and as many different versions of Android that you can actually get Unreal Engine 5 to run on. You can make a device profile for them. And they're not limited to just settings. You can do things like texture resolutions, level of details, post-processing, rendering features. So there's a ton of stuff that you can do for each of your platform. So there was some information on that. The next one we have is optimizing build size. So this is set up just a little bit different. There's some project content and tools. So for your project, you can remove unused plugins, can help reduce your build size. The thing about this, though, is I would remove a plugin, repackage your project, and then run it to make sure that you didn't remove a plugin that is required somewhere else. You can use forward shading, can reduce the size of your build, but that is going to greatly affect your artwork and your features. So just keep that in mind. Removing unused engine components can also help reduce the size of your overall build. So inside of your engine folder, there are a bunch of assets and textures that are used that are very large. You could, if size is really that important, you can actually shrink those down to get a lot of size back. For your content, using ASTC texture compression can reduce your build sizes. Specifying a minimum LOD to use. What this means is that Unreal has a very intelligent LOD system. So let's say that I have a mesh that has 5 levels of detail on it. I can actually tell the level of detail system that when it's published for a mobile platform, instead of using all levels 1 through 5, only use maybe 4, or just strip everything from 1 and just use the last level of detail. And that can also save you some memory. Reducing texture sizes and shader permutations. So let's say that you have your device profiles set up, and inside of there, you can say that on a mobile, if this 4K texture should be reduced at cook time to, say, 1K texture. Or on mobile, I don't use the, let's say I'm maybe made like a cave style game that uses spotlights and point lights, then I can reduce or uncheck in my rendering settings, use skylight and directional light shader permutations, which will remove that, helping reduce the overall size. There's also some tools that you can use to help visualize this. So there is the size map reference viewer. This will help you to visually look at how your project is, what assets are kind of the biggest. And instead of looking at it through like a list or something, it shows you this really nice visual representation, which to me makes it a little bit easier to see and make better decisions. The device profile manager to help set up and update your device profiles. And there's also an Android and, or I should say, mobile preview in the editor. So you can turn your viewport into a really great representation of what things are going to look like on your Android or iOS device. But remember, I said representation. It's not a one-to-one. It is as close as we can get, but you should always be testing on your device as a couple times a day just to make sure that everything is working. Now, there are a bunch of other things that we can talk about for optimizing build size, especially for Android, that you can find using this doc page right here. And with that, I am going to be wrapping it up. So I will open it up now to any questions that anybody might have. And yeah, we'll go from there.
Awesome. Well, thank you so much for walking through those slides there. A lot of very helpful information, learning about some of the tools and stuff that is available. Yeah, we'll dig right into some of the questions that we've been collecting from chat so far. And if any other questions also pop up through the process of us answering these, there's still time. So just pop them in chat whenever you have them, and we'll collect them and address them here. So first question I've got for you, Sam, is someone was curious if mobile deferred shading, if there's something equivalent to that that can be used for non-mobile games as well.
So there is. I'm gonna switch over to my the editor really quick. Could you just cut over to that?
Sure.
Yeah, there we go. So there is under, I think it's project settings. Hold on a second. Everything's on my other monitor, so I gotta just click it over here.
Pull it over, yeah.
Yeah, which is weird because I'll do that and then I'm like, oh, I'm doing something on my other monitor and I have to pull it all back. If we go under to the rendering, there is this forward. There we go, forward renderer. So the forward renderer, when you enable this, it is going to give you a forward shading like support, so you get MSAA, but this is mainly more targeted towards VR development. You can use it, just keep in mind that when you enable this, it is going to completely change how the renderer works, so all of your artwork is going to look a little bit different. So this is something that you'd want to enable at the beginning of your project to see if it kind of meets the needs that you want. So just keep that in mind.
Awesome. Thank you. Next question I've got here for you is someone mentioned that they've been trying to get per instance random nodes for materials working on mobile for HISM objects, but it doesn't seem to work for them. Is there any technical reason why something like this might be happening?
So I'm not sure if hierarchical static meshes work because of hardware, of mesh hardware instancing. I don't have a definitive answer like, oh yeah, that should totally work. The other question would be, is it not working in the editor or is it not working on device or both? It could also be too, so phones have different GPUs in them. So even the same device, like you could have a Samsung Galaxy S13, but you could have like a different processor in it than something else, than the exact same model that's sitting next to it at Best Buy. And in some instances, some things can work on one, but not the other. So that's why I always say test on device. It works in editor, not on device. Yeah, that's probably because it's not supported on device. But it's very, very hard to tell because again, you could have two of the exact same devices that run the same OS and everything like that, but under the hood they have different hardware that you don't actually really realize that. So things might work on one device, but on this exact same other device, it might not work. So yeah, I don't know of a technical reason why it wouldn't work other than it might not be supported on the device that you're deploying to. It's the only thing I could really think of without really like having to dive down into it.
Yeah, definitely. Awesome. Next question here is someone's talking about landscape specifically. The landscape feature uses a lot of memory and increases draw calls. And they've converted the map to static meshes, which has improved performance. But besides LOD, virtual textures, and organized design, is there anything that you would suggest that could potentially help with that memory and draw call issue they're encountering?
So you can reduce the tessellation of your terrain. It doesn't always have to be at like LOD 0. You can kick it back. with the terrain, one of the things that you're going to lose is the really great collision that it comes with. And the problem with static mesh is getting the player stuck. So capsule glides kind of seamlessly across the landscape, and that's because it's just doing a 2D lookup to the pixel that's underneath it. And there's no way for me to get snagged on a collision. And what I mean by snagged is like as your player capsule is going over something, when you go over the landscape, it's moving up and down. Like there's not a way for something to get interpenetrate that capsule. Same cannot be said with a static mesh. So the problem that you run into is that yes, you've increased performance, but you've opened up a testing issue because now you've got to make sure that no matter where you walk in the world, the player can't get stuck. One of the workarounds for this is if your device can support it, I would suggest that you convert your terrain to nanite. There are some higher end devices that support it, but I'm not sure if you have to run the mobile, like the mobile forward desktop renderer. But what I will say is that if you use HLOD, you should be able to get it to run on an acceptable frame rate. Because I know that Fortnite uses the same landscape system that's available in the editor. All right. What other questions do we have?
Okay, I wasn't sure if there was follow-up there, which is why I was waiting.
No, that's all that I had. Sorry.
No, you're good.
Should have been more clear.
Next question I've got here for you is, would you say Gauntlet is a worthwhile addition even for small teams or solo developers who might not have the same amount of time to dedicate to that resource?
Yes, I think it totally is. It's just be aware that there's an upfront time sink to get it working. And I don't mean like time sink as in like, oh, I'm going to bang my head against the wall to get this working. It's just you need to figure out how you're going to get it to work within your pipeline and then set everything up. So it's I'm going to equate it to like kind of like making a garden. Like the thing that sucks the most about making a garden is having to get everything ready in the springtime. You know, there's an immense amount of setup, but once you do all of that, you get everything set up. The rest of the year is pretty easy to do with, you know, just little bits and pieces like weeding or cutting stuff back, and then you know, you reap the fruits of your reward, so to speak. But yeah, there's going to be an upfront cost and a little bit of a learning curve because it might not be your area of expertise, and especially if you're on a smaller team, you might, you know, I know people on smaller teams wear many hats, so you know it might be maybe one of the lead engineers that has to set it up or get it working. But I think it would be super beneficial. Yes, I totally think it would. It's that initial cost or that initial setup that that it could be a little daunting or take a little longer than you expect, but I think it would totally be worth it.
Awesome. Next question is, do you think these processes and tools would also help with developing for handheld devices like the Switch, etc., and not just mobile?
Yeah, so I say mobile, but this is really more, and the Switch uses a mobile processor, or what we would consider to be a mobile processor, and the handheld devices like the Steam Deck and things like that, they are still considered a mobile device or, you know, a mobile processor. Yeah, this would all apply to that. The only area where it would start to be a little weird is like trying to do like console, because consoles are still a little bit more powerful than mobile devices. And mobile devices are also like general purpose computers, where a console is kind of more set up for specifically for gaming. So if that makes sense. But if you were targeting like the Steam Decks or whatever a new handheld thing is, and stuff like that, then yeah, I think this could be totally applicable to it.
Very cool. Next question I've got here is, are you aware of any potential conflicts with world partition offset in materials on mobile specifically?
So wait, say that. World position offset and
In materials for mobile
materials.
specifically.
So one thing with world partition offset is what you're doing is it's a very clever trick, because you're basically skipping the CPU and you're telling the GPU to do something. And so it's just it's a very clever, like, visual enhancement. While some of it will work, the issues become, well, how far is it away from the center? Because remember, mobile is going to be reduced CPU and GPU, but also not in speed, but also in, like, just the power of it. So you might run into, like, floating point issue errors where, things get wonky. That's not to say that they're not powerful, but you just need to account for that. Let me think what else. Yeah, and it also, again, remember, make sure you test on multiple devices, because what could be working on, the latest version of iOS or Android, maybe that doesn't work so well on a previous version, or on the same version but on a device that is, lesser powered. Those are the things that are really, that's the hardest part with kind of mobile development, is because there's so many different devices. It's like trying to figure out, like, this works, but then it doesn't work on this exact same phone with this exact same feature set because it has this different GPU in it. There's issues like that will come up, and they're very hard to be like, oh yeah, you need to do this or you need to do that. Also, because I don't do mobile development that much anymore, it's hard to know, like, what all of those will actually be, if that makes any sense at all.
Yeah, absolutely. Next question. Oh, this is a big one, so feel free to take your time with this one. Have you seen any common mistakes when developing for mobile that these tools help avoid? And if so, what are they, so we can attempt to avoid them ourselves?
So the biggest mistake I see is people, or that I shouldn't say that I see, but that I've heard about, that, like, an engineer was talking about, and I was like, oh, this is something I should probably commit to memory, is using too many materials, too many unique materials. So, like, instead of having one or two environment materials, we have 30 environment materials, or saving the unique materials for where they're really, really, really needed, like your characters or your guns or objects you're trying to sell, or just, and then on mobile, think about your asset reuse, right? Like, back in the old days, devs would do things like make the tops and bottoms of sidewalks different. So one sidewalk, like, you have it like this, and it's got a design on it, and then you flip it upside down, it's got a completely different design on it, right? That's just one asset, but two different uses. Or you could flip it up on its side, and now it's like the street molding or whatever. I can't think of the name of concrete curbs. So, like, that's one asset that's got like three different uses. So it's thinking about clever ways that you can reuse your assets to help reduce the amount of assets that you have. And then these tools are really meant to help you. There shouldn't be a point in your project where all of a sudden you're like, oh my God, we have like 25 gigs more memory consuming than we should. Like, there should never be a surprise like that. You should always be looking at the tools to understand, like, oh yeah, the reason why we have this, giant 85 meg texture or 100 meg texture is because it's used in 6 different locations. So it's worth the cost to have that. you should be using these tools at all times to help make sure that if you do encounter like an error or something, it's not, it hasn't been lurking there for 6 months or something like that. You can use these tools to help you figure out those problems sooner so you can address them. Yeah.
Very awesome. Next question here is there any way one can use Nanite with high resolution assets for mobile development?
So eventually, yes. Right now, not that I know of. There's an apostrophe next to that. You can run a version of the desktop renderer on high-end mobile devices, and that could support Nanite and Lumen, but it runs at like 10 frames a second, so it's like a really interactive slideshow. But it is possible to do. In the presentation, I think it's in like the mobile. There's a mobile rendering guide on the documentation, or you could just type in like UE5 desktop renderer on mobile, and you'll find a way to enable it. And it will give you the full desktop renderer on a mobile, but it won't be very optimized, and it won't run the greatest, but it will still work. So it make a really great like slideshow presentation, but don't expect it to be like an interactive frame rate. And with that said, though, as mobile devices become more and more powerful, eventually it will be on there. It's just a matter of time. Like, I started my career right before VR became really, really popular. And so like I used a Samsung Galaxy 4 for like Gear VR for like the longest time. And, now I have like a Pixel Fold that is infinitely more powerful than that thing will ever be. And that was, 5-6 years ago, maybe even longer. I don't remember now. But the point is that it's coming. It might not be here yet, but it will be there eventually.
Yeah, I feel like that answer actually very smoothly transitions into this next question I have for you. Someone said, with advances in handheld technology, I feel like the gap between what a mobile device can handle is getting smaller. Or should I still be developing with older tech still in mind? And so, how many generations back do you feel I should accommodate?
So that's entirely up to you. I can't really say, oh, you should go back 6 generations or 5 generations. It's really like, how much work do you want to put into supporting older tech? Because there could also be a point too where things don't run because like the SDK isn't updated, and it's not an SDK that you can update. I would more look at, how do I want my game, like pick something that's, maybe 2 or 3 years old, play your project on it and see if it plays the way that you want it. And see if it actually functions, something that still feels like your project, because just because it could run on something doesn't necessarily mean that it's going to run really well. Like I worked on Action RPG, which was a mobile game that we made to help teach people how to make games on mobile devices. And there were some very low end devices that the game would run on, but it didn't look very good, or there were a lot of FPS spikes, so it didn't play very well. So yeah, sure, the game supported across like 500 devices, but out of those 500 devices, there were like 50 that I had to straight up just like deny because it just wouldn't run. And then there were probably like another 75 that I should have like cut. But dude, 500 devices, one person, that's like weeks of testing. Because you got to think that I could test the game on one device or do like a virtual test setup. Not to go too far in the weeds, but even with our like testing lab, I could only test like 10 devices a day or 15 devices a day. Just with all the stuff that I was testing for, and then like getting stuff to work. And like, you're thinking like on a good day, well, what if the charger cable isn't there? or somebody's taken the device, or somebody needs the device. It's just, there's a lot of things that can come up, and it takes a little while to test stuff. That's where like things like Gauntlet really come into play, because you can have it, well, I know I want to support these 10 devices. So you go out and you get those 10 devices, and you can use Gauntlet to then, set up to push to those 10 devices so that you can see every day, like, okay, great, everything is running on these 10 devices. As you increase that device amount, and then you start trying to do like virtual testing, yeah, you'll increase your reach, but it's a virtual test. It's not guaranteed that it will actually work on the hardware. That's why I always suggest that people have the hardware there, because you'll just get a much better idea of it's actually going to work or look the way that you want it, and be something that is representative of the quality that you wanted.
Mm-hmm. Yeah, for sure. Speaking of Gauntlet, and you kind of brushed on this in the actual presentation, but they might have missed that part of it if you don't mind kind of just reiterating some of this. But someone asked what the difference is between Gauntlet and Unreal Insights, and if they can be used at the same time, or if they do more or less the same thing.
So it's a great question. So Unreal Insights is for investigating, let's say, down to the byte, or down to the memory buffer, what your project is actually doing. So it's giving you information about what files are being loaded and what is happening in the order of events of your program. So it's more about performance and how my project is actually running. Gauntlet is more set up to do things like test for and give you information about your project. So here's a great example. Your project is running and you're using Gauntlet to load up the game and load up a multiplayer. It loads up the game, loads up your multiplayer, spawns 2 people in, and that crashes. And you go and you look at it and you're like, it just says like assert failed on this particular file, and then it just like, it gives a bunch of garbage. Well, you can use Gauntlet to collect all that information, and then you can use Unreal Trace to look at why it's actually crashing at that one particular location, or to help you give you some more information to figure out why it's crashing there. So again, we'll use Gauntlet to help manage and give us stuff to look for or test against, and then we use Unreal Insights to give us more information about why something either crashed, or if we're trying to investigate why something is running slow.
That makes sense. Next question here is, can UE5 pre-render high-resolution scenes when loading and then stream them as enhanced images to reduce performance lags? Or would a process like that create more lag on something like a mobile device?
So that would probably create more lag and more. Just don't forget, you'd have to like store those images somewhere, and it would probably be more memory. What you can do, and console games do this, you can have them download like the bare necessities and like the first or second bitmaps, and then as they start to play, more things will be downloaded. That is possible, but that's not an out of the box solution. You'd have to set something like that up. But that is totally something to do, that you could do. Remember, if you're gonna like have a visual representation of something, it's gonna have to have pretty high pixel density. So like, or pixels, not to get too, but pixels is what you refer to as the pixel content, but it's going to have this really, really high density of them in order to give you the quality that you might be looking for. The other thing that you can do too is, this is where like HLOD, hierarchical level of detail tools, would come super handy, because what they do is they basically go out and make a version of your level and give you brand new mesh and material. It's just a lower poly version. So you might be able to get away with something like, streaming in that while something is loading. So that might be able to do something. But it might end up just costing you more memory, or just not being as performant as you're thinking it might be.
Yeah, for sure. Next one is, do numerous high-resolution textures on low-poly assets create more draw calls than high-count geometry with low-res textures, or is it the other way around? What's the best compromise?
So there's a couple of things here. So your texture resolution doesn't have any direct impact on your rendering. It has more of an impact on like the project's size on disk and how long the project's going to take to load. A draw call is basically when you have a static mesh. Let's say we have a cube, right? So cubes have 6 sides. So if I put the same material on that cube, I'm going to have 2 draw calls. I'm going to have a draw call for the cube and then a draw call for the material. So if I put a different material on each side of that mesh, what I'm going to end up with is like 7 draw calls, 6 draw calls for the materials, 1 draw call for the mesh itself. So the best option to do is to actually establish a budget for your assets. So for example, let's say that you're working on an open world project and you have like houses. So houses could have, say, 3 material IDs. They can have one for the floor, and then one for the walls, and then one for the ceiling. And then let's say outside, they can have like just 1 material ID or 2 material IDs. And then for all objects, that are like, smaller than the player, they can only have 1 material ID. And so that way, what you're going to get is a better way to go about managing these. And then, if a player might have, 6 of them, it's best to figure out where you want to spend your detail. And then kind of like if you're really want to have a detailed player, that's totally fine. Then you spend your resources there versus putting them somewhere else. So it's not necessarily that one method is better than the other. Like you said, it's more you need to come up with a plan and stick to it. That way you can make better calls about why your performance is so poor in the future. Or if somebody else is coming onto your project, you can let them know like, hey, here's how we do things. So they're not accidentally like bringing your performance down because they're introducing stuff the wrong way. So again, just to recap, textures are going to impact your like memory size. The amount of materials that you have on an object is going to affect your draw calls. So they're kind of 2 different things.
All right, awesome. Well, that's going to do us with the chat questions for now. I do have one final question for you. It's my surprise question, and it's always kind of deceptively harder than it should be. But if you had to condense down basically all of the information and everything that you've gone over today into one piece of advice that you would like to give to any devs watching, what would that advice be?
Use as few materials as possible.
Easy. That one was easy for you. You had that one down pat.
yeah, that's going to be one of your biggest issues with mobile devices, is the overuse of materials. So use as few materials as you possibly can. I always say build your content like it's 1999. And what I mean by that is, think about a mobile device is like where a computer was in the early 2000s. And but it's inside my pocket, right? Maybe it's a little more powerful than that. Maybe it's like 2005, 2010. Not quite the Maya apocalypse yet, but if you think about it like that, and kind of do that as your target, you'll have a better time, I think, developing especially for mobile stuff. And then pick projects that are appropriate for what you're doing. Super interactive, like the next gen style Sims might not. Well, no, it probably could run on a mobile device. It's really about picking the device that you're gonna your target device categories, I guess. Like I'm a Pixel user, so I'm gonna target, Pixel 5 to the latest version or whatnot. Instead of trying to cast a net out and be like, I'm going to do all of Android phones, or I'm going to do all of Android phones released in the last 3 years or something like that. Pick some like main flagship devices and be like, hey, our game, we know our game runs on this really well. And that could help you understand your target audience a little bit better, or help you just make sure that things work the way that they're supposed to. Because again, the market is so segmented that it's a lot easier. It's a lot easier to make your game for a console because everybody has the same power settings, the same hardware. Mobile development is a little bit more difficult because, well, now everybody's got a different set of hardware and things like that. So we've got to make sure that what we're doing is going to work across all the platforms, or all the devices that we support anyway.
Right, yeah, absolutely. Well, thank you so much for coming on the show today and talking about this topic with us, walking
Thank you
through
for
all
having
these
me.
different tools and stuff. Yeah, of course. I really appreciate you being here and doing this. It's a great topic. I feel like there's a lot of questions constantly revolving around it, and this should hopefully help a lot of folks take some of those first steps to getting their project to work better for them. So thank you so much again for taking the time to do this.
Not a problem. I will talk to you all next time. Thank you so much.
Yeah, thank you so much, Sam. And thank you so much, everyone who came to watch the show and participate, ask questions, all that. The show wouldn't be what it is without you and you being here and your interaction. So thank you all for taking the time to be here with us today. If anyone hopped into the show partway through, you missed some of the content, or you just want to go back and review, because there was a lot of information and a lot of really great links to documentation too. No worries. We post all of our streams in video format that can be viewed on demand on both our Twitch and YouTube channel at Unreal Engine. You can also keep up with us at Unreal Engine on all of our socials to keep up with the latest news, updates, all that kind of good stuff. And lastly, if you haven't already, I also highly recommend and encourage that you come join us on the Epic developer community. That's where we house our forums, our documentation, tutorials, learning resources, pretty much anything and everything you could ever need in regards to the engine is available there. So go check that out if you haven't already. It's a great resource. And that'll be it for us today. Thank you so much, everyone, and we'll see you next time. Bye, everyone.